otherwise known as a network engineer. And today I'm going to talk a little bit about monitoring and troubleshooting in a large-scale network like Facebook's. So first thing is, why am I talking about this? What is the problem that I'm trying to solve? And you might find yourself saying, packets are getting there, there's no problem on my network. When something goes wrong, all the blinking lights turn red, everything's good, right? Well, if that's the case, your network probably looks something like this. You have some servers, you have some switches, you have a core, and of course it's all connected by a series of tubes to the internet. And of course, then you have some monitoring system, you have a syslog server, reachability server, graphing server, whatever. Okay, so if your network looks like this, your troubleshooting procedure probably looks something like this. The guy calls and says, hey, I got some packet loss on the network. First thing you do is confirm the issue. You ping the servers, you see that there's packet loss, great. Now where's the packet loss occurring? Well, you run traceroute. You run this traceroute, you see, okay, it's at hop 3 of this path. There's some problems occurring. So you log into this device, you run show interface, you run show log, shut down some random ports. If all else fails, you call your vendor and you say, help me out, I don't know what's wrong. If that's your troubleshooting procedure, you're right. That is easy. We're done. But, and this is a big but, that's not my network. And the chances are it's probably not yours either. My network looks something like this. I have a lot of servers, I have a lot of aggregation layer, and I have a very large core layer. But in addition, I'm a very large content provider, so I've also got an edge layer and a backbone layer. And of course, if I have a backbone, this means I have data centers. If I have data centers for redundancy, I probably have regions. And of course, this is all connected to the internet by a series of tubes. So, this is the part I'm very happy with. As you can see here, I wrote a Perl script last night to show every single interconnection on our network in real time right now. It continues. That's it. That's exactly what the path looks like in our network. Now, of course, any large-scale network is never complete without its requisite set of lions, tigers, and bears. Okay, I'm exaggerating slightly. We don't have any lions in our network, but the bears and tigers are real. So, let's talk about troubleshooting in this scenario. Okay, first off, you need to confirm the issue. You run ping again, but that doesn't really work because we're using ECMP and lag. The ping is not going to follow the same path. All right, well, let's run traceroute. Same problem. Packet's not necessarily going to follow the same path that your data is following. So at this point, I'm starting to freak out, and the guy on the other end of IRC thinks I'm an idiot. So I start running show int on routers. I start running show log. I start shutting down random ports. But honestly, I don't know which one. I don't even know where my packets are. I don't know whether they're alive or dead. So this is the phrase that comes up. It must be a network issue, right? How many times have you heard that? At least 100, probably today. And the reality is, can you really blame them? Because they don't really know any better than you, and I don't really know half the time if it is a network issue. The guy comes up, says there's something wrong, and I'm like, nah, dude, it's not a network issue, everything's cool. But let me check a few things. And the reality is, I find out later, it is a network issue. Fair enough, it's broken. So what can we do about it? Well, I've been thinking about this for all of maybe 6 months now, and every day I go to work and troubleshoot another issue, and I try to figure out what I can do to solve this. So some of the things we've come up with is something better to trace the flow of packets in our network. I looked at a nice NANOG presentation from a few years back called TraceFlow. Essentially, it's traceroute, but it gives you the full path all the way end to end, including all the physical interfaces inside of a bundle that a packet's going to follow. In addition, to do that, you need the full tuple that you're actually looking for. What I mean is the source IP, destination IP, source port, destination port. To get that, you run hping, let it run, and it'll go across a series of source ports, and then you can find out which ones failed. Great. Now I know what's failing. Now I can run traceflow and figure out where it failed. In addition to that, we need something real-time to monitor this all the time. Why not just have all the hosts and all the routers run hping constantly? When they detect a problem, send out a traceflow, send me some syslog back saying you're getting packet loss at this point. That would be awesome. In addition, BFD. BFD is really cool. It's starting to get support from the different vendors and different protocols. But we'd also like to see it per interface in a lag bundle. Once you get that, super awesome. Next, more granular counters. 30-second counters were not cool in 1999. They're not cool now. I need better than that. Half my problems come and go inside of 30 seconds. I spent all last weekend working on an issue that lasted for 1 to 2 seconds at a time. It was horrible. Next, I want to pull more. I hear quite often, I'm working on an issue and I finally get to the point where I have to call the TAC, and he, asks for output from a whole bunch of different commands, and in the end I say, cool, let's graph this. Let's add this to our grapher, and I finally realize that it's not an SNMP, it's not an XML. I can't get this data out of the router, and that's not fun. I understand conceptually why that is, but it's not cool, and I can't graph it. That's a problem. Which brings me to my next point. I want to pull it less. And I know that's counterintuitive because I just said I want to pull more, but what I mean is when we hit a critical issue, I don't want to pull the router. I don't want to wait 5 minutes. I want the router to send out a packet and tell me something is wrong. I've run into a critical issue. You need to do something. Now, why do I want to do that? Well, as one engineer at Facebook once put it, today, when we're looking for a problem, we go to the router and say, hey, router, how you doing? He's like, bro, I'm doing great. But the router's insane. He doesn't know what he's talking about. We need to test through the device, we need to test to the device, and we need to ignore what it's saying and prove what's going on. And lastly, and this one's really important to me and to Facebook in general, let me pop the hood. Let me get in that router and let me run Perl on it. Let me run Python on it. Let me connect to it via OpenFlow. Let me do something. So, okay, I've complained for 10 minutes. You get my point. There's a problem. Now what? Well, the reality is I don't sit around thinking about this all day. I don't do research on this all day. And we have a very small team at Facebook. So we're here to ask for help in this. You know, if you have better ideas on how to solve this problem, if you already know how to solve this problem, great. I'd like to hear from you. You can subscribe to me on Facebook. You can message me on Facebook. You can email me. It's very difficult. It's ph@fb.com. Thank you.
Very nice. So coherent and fast. I like that. Any questions? Questions? No? Aha. Identification, please.
About one. Anton Capella, 5 Lines Data. Have you had any experience or empirical measurements yet made about comparing, let's say, active probes versus passive measurements, such as for packet loss or congestion? Have you had a chance to take the available examples and compare how well one or the other is not maybe telling you the reality?
So you mean like the difference between sitting there and waiting for a pull or me to pull something versus the device to tell me something?
Oh, I mean something even more mundane. For example, a congested link exists somewhere. We don't know where.
Sure.
There might be a transmit discard counter. Mm-hmm. There's also a ping flying in some sort of matrix between the end nodes or the underlying infrastructure. When do you see them correlate, or do you ever? If you don't see them, I mean, have you considered, whether or not either of them is telling the right story?
Yeah, I don't know that I have like really precise data on it. What I do know is, the way I graph things is, might sound silly, but I take every error counter I ever know of any device. I take every device and I roll that up into one giant graph. And if the little line goes up, I know there's something wrong somewhere, right? So then I start doing that. But sometimes that line doesn't go up, and it doesn't go up because of bugs. It doesn't go up because the device isn't reporting it. It doesn't go up because there just isn't an error counter for whatever the problem is. So in that case, that's when I want, something to actively monitor to tell me.
Got it. So you're saying you almost need both?
Yes.
Active probing plus passive measurements?
Absolutely, because just like the routers can have bugs, my polling system can have bugs, so I need both.
And 2 nines per each system gives you how many nines in total?
In terms of uptime?
Rhetorical.
Yeah.
Thank you.
Thank you.
Very nice.